Hello student, good evening to all. In this classes students, we will discuss the force due to continuous distribution of charges. Yes, force due to continuous distribution of charges. How we can find the force? You know that whenever the many charges shift on line, we can shift on, we can distribute it on surface, we can also distribute on volume. So students, now we have first I have taken here when charge is distributed continuously along a line. Yes, definitely. Before it I had taken, suppose that this is the lines and its length is L, and suppose that many charge is distributed, and you can assume that Q is the charge, Q is the total charge, and L is the length distributed. Then if you will find totals, what is the linear charge density, then simple you will write, sir, Q is equal to L. Definitely you will write. And if you will find the value of Q, so here will be lambda L. Very good. But you know that whenever we will find out for elementary portion, you know that in physics, in the mathematics, first if there is no particular measurement, then we take simple the elementary portion. Yes, and you know that by the help of the elementary portions we can integrate these ones, then we will get the total amounts. And suppose that if we have the bigger the total, then we can differentiate these ones. Means bigger to smaller, but first here we will find out here the elementary, that is small to bigger. Very good. So you can see that I have a line, that is the linear charge density, and this one I have placed in the coordinate frame. Yes, what is called this one? Coordinate frame. Coordinate means this is the x-axis, y-axis and z-axis. Very good. So you can see this one x-axis, y-axis and z-axis, and here I have taken here R, vector R and R dash. What is R and R dash? The position vectors. Yes, this is the position vectors, and I have taken a length, and many charges distributed over it. Suppose that the total length is L. Suppose that total length is L. So elementary portion here will be, suppose that A and B the elementary portion, so its elementary portion will DL. And here is the Q naught. Q naught is the test charge. Yes, test charge due to which these ones the here will force experience. What will be the value of that? With the help of Coulomb's law and Coulomb's law in vector forms, we can find out this one. Students. So but before finding the value, you know that in physics we have to represent everything. So what is Q naught? Can we represent? Yes. Very good. So Q naught equal to test charge. Yes, this we can write vector R and R dash equal to position vector. Yes, position vectors. Very good. DL equal to, what is DL? Elementary portion. Elementary portion or length. This we can write. Now we see that if we can write these ones, then how we can find out the small amount of charge? You know that the charge on length, elementary length, and also we can find out the force. So you know that force on charge Q naught. Show force on charge Q naught. Q naught, that is the here is the Q naught. So force on charge Q naught due to dq, you can take here elementary portion due to dq on the length dl here. On the length dl. So what you will write from the Coulomb's law in vector forms? You will write df equal to 1 by 4 pi epsilon naught q1 q2 by r square can be right here. So q1 that is q naught, and we have here's what you will take dq, but you have to find out the value of dq. Okay, no problem, you can take here dq. Okay, by r square, but you know that in the Coulomb's law in vector forms we had multiplied on the RHS side, okay, in numerators and denominators, so we got the cube terms and we got the value of, okay, r and r vector r's with the help of triangle law of addition of vectors. Yes, so you see that here same things are there that we can find out here, mod of vector r minus r dash mod of q, and here will be same things into vector r minus r dash mod of q. This you can write, but we have to find out the value of dq. Okay, so how you will find out the value of dq? Since you know that lambda is equal to q by l, so or you can write lambda is equal to dq by dl, can be right, cross multiply here. So what you will write, dq equal to lambda dl. Yes, that you can write here. This value we can substitute here. Therefore, what you will write? Therefore, df, okay, vector df equal to 1 by 4 pi epsilon naught q naught, at the place of dq you can put here lambda dl. Yes, we can write here vector r minus vector r dash and mod of q. Okay, mod of q and multiply, here you will write same things, vector r minus r dash. This you can write. Okay, so we got the force on, okay, we have these elementary portions, but we have to find the total amount of force. But how you will find out the total amount of force? You know that to get the total amount of force you have to integrate this one. Okay, so simple things you can write here. Therefore, total amount of force, how you will find? F equal to integration of df. This is the formula. Okay, very good. So you can write these ones, and you know that this is the linear charge density, and suppose that L is the total linear charge density, you can write here. See, yes, and you can put this value at df equal to you have. So you can write here vector f equal to integration of 1 by 4 pi epsilon naught q naught lambda dl divided by vector r minus r dash mod of q into vector r minus r dash. This we can write. Okay, and now this you can write q naught, and this the constant you can write outside, or you can write here vector r, okay, sorry, vector f equal to 1 by 4 pi epsilon naught q naught integration here, and here will be lambda dl divided by vector r minus r dash mod of q, and here will be vector r minus r dash. This we can write here. Okay, and you know that we are integrating, so total length, here is suppose the total length is L, then you can also give here L. You see that this we got the force experience by distributions of the continuous charge on a line. Yes, you see that these ones. Okay, very good. So this is the final answers that we can find out. Yes, you can also integrate, but this you can write yes. Okay, students. Okay, so you should write these ones. Okay, thank you. Okay, so next we will discuss more. Okay, whenever we will take the charge on the surface, similar manners you can also take, just like we have taken here. When many charges distributed over a line, you can also take the surface, you can also take, we will take no problems one by one, but next class, next, okay, class we will take whenever so many charges are distributed where on the surface. Okay, we can find out, and you know that whenever we will place the charge then how much force we'll experience, and that we will calculate whenever we will solve the numericals. Okay, so numerical is coming way for some classes. After that we will start related discharge. So many questions are there. Okay, so we have to solve, but before solving, this is the homework that you can see. Yes, and you will say, sir, why are you giving the homework? Okay, just you will revise one times. I think that one times you will see. Okay, you can do itself. This is not okay hard, this is easy. Okay, okay student, thank you.